Welcome to FET106 Basic Theory. So here we're going to be looking at reverse Polish notation or postfix notation. And the reason for looking at this is that it reduces the access to memory in computers. So which of the following is an arithmetic expression that is represented as EF minus G divided by CD minus AB plus divide plus, with reverse Polish notation or postfix notation method? So we've got four answers below, and we're going to see which one in normal infix notation, as it's called, because the operands are in between numbers if they are being operated on, which one of these is equivalent in reverse Polish notation. So reverse Polish notation, let's have a quick look at what this is. So RPN is a way of representing mathematical equations. It is also known as postfix notation and is parenthesis free as long as the operator arities are fixed. So for example, let's look at x plus y all divided by z. It means that x is added to y and then z is divided by the result. So if we look at just the first bit, the x plus y in brackets here, in postfix notation or reverse Polish notation, this is represented as xy and then a plus. So x and y are then added, is how you could read that. So therefore the whole expression is represented by this notation here. So xy is added together and then z divided by these. The order of the operators is considered and the notation is made without parentheses. Okay, so let's write down the equation that we've been given. It's EF minus G divided by CD minus AB plus divided by plus. Okay, so this is the equation that we were given on the previous slide, and let's see if we can convert this back to the normal notation that you're used to using. So let's first of all look at the first operator, which is minus, and that is going to be performed on these two terms here. So let's write below E minus F. Nice and simple so far. Let's then move on to our second operator, which is the divided, and that's going to operate on the previous set of examples. So this is going to operate on E, F and G. So it's going to basically operate between these two. So if we go back, E minus F is then going to be divided by G. Okay, so then we're going to move on to the next operator, which is this minus here. And this minus is then going to operate on the previous two terms. Well, in this case, what we've got is we have that C and D are the previous two terms. So we kind of move on and ignore this set of terms that we have here and do C minus D. Okay, and then we move on to the next operator. So the next operator we have is this plus, and that's going to operate on the previous two terms again, which is A and B. And we can write that here. We again move on from this set of terms, and we have A plus B. Okay, and then we're going to start getting to a slightly trickier stage where we're looking at this divide here. So now we're going to be looking at the previous two terms again. And the previous two terms in actual fact are going to be whatever this C and D has occurred on and whatever has occurred on A and B. So it means that we end up with actually a divide in between these two terms here. And finally we look at the plus on the end, and that is going to be operating between these two terms overall. So the first term and the second term. So all we simply do there is put a plus in between and finish off some of our parentheses, and we have our full term. So let's just write that out one more time. So we've got E minus F divided by G summed with C minus D divided by A plus B. And that is the same as this expression up here in reverse Polish notation. So let's look at this explanation in words on the next slide. So let's just walk through the explanation that we've just gone through. Here is the equation that we started with. And as we mentioned, E and F are the subjects of the first operator. So this means that it's going to be E minus F. The subjects of the second operator, which is divide, are the result of E and F and G. So the parentheses added in line with the operator priority, and expression becomes E minus F divided by G. Next, the subjects of the third operator, the minus sign, are C and D, and this becomes C minus D here. Finally, the fourth operator, the add, the subjects are A and B, so this simply becomes A plus B, as we mentioned on the previous slide. So next is when we get to that tricky part. The fifth operator, that divide, is going to be between the result of C and D, C minus D, and A plus B. So the expression becomes C minus D divided by A plus B. The subject of the final operator, the addition, is the result of E minus F divided by G and C minus D divided by A plus B. This means that the final expression becomes here, which is E minus F divided by G plus C minus D divided by A plus B. And therefore D is the correct answer. And so what we can see here, as we mentioned on the previous slide, is our answer is D. So what we've learnt here is a new form of arithmetic notation called reverse Polish notation or postfix notation. And this is more friendly for memory access in computing applications.